with the webinar. Okay, so welcome everyone. We are today very happy to welcome Marc Vanhoutte. He is a UITP Honorary Member, former very dear colleague, and now consultant in Marc Vanhoutte Consultancy. We will be discussing today the topic of planning for clean bus deployment. Marc is an expert on the matter, and you will be able to have a very good overview. What are the different steps? As you know, in the Clean Bus Europe platform, what we are trying to achieve through this webinar series is definitely give you the most complete insights into the different stages of clean bus deployment, not only. And this is one of the first steps. So I was saying, Marc has been in very important leading positions. He was also workshop and technical manager at Veolia Transport in Belgium. You will know him most likely also because he was the bus fleet manager at Transdev in Paris.
Clean Vehicles Europe, that was strategic.
Yes. I think the ones in the run today definitely know Marc very well. And as I said, he is a very dear colleague and very appreciated by UITP members and staff, of course. And now he's already sharing his expertise as a consultant for Hansea in Belgium. The program for today is very straightforward. We will have a presentation of 40 minutes by Marc with the different aspects, an introduction to the planning, also a short brief look to the stakeholders involved, which are the stages and the timeline for deployment, also a bit of information on preparing for tender and commission operation, and we will focus on the case study for battery bus system. At the end, we will have questions and answers, so feel free, please, to share your questions either through the chat or raise your hand. I think it's nice to have an active discussion, so of course, feel free to raise your hand and open the camera if you wish so I can identify easier who would like to have the word. As I said, the goal is basically to share with you as much information as we can on planning for clean bus deployment. But today we very much hope that you will be leaving the webinar with a clear understanding of the main aspects to consider when it comes to the deployment, with the focus, as I mentioned before, on e-bus technology. And I think just a brief reminder on the etiquette for discussion, but I think everyone already knows this very well. As I said, as a reminder, the session is being recorded. If you would like to address a question, please raise your hand or use the chat to do so. Yeah, and I kindly remind you also to please mute yourself for default. And I think now we are all set up to go. I give the floor to Marc. I'm ready when you are, Marc.
Yes. Okay, so we were ending. So also from my side, very warm welcome to this presentation. The first thing is that you see in the past I have seen that people are starting with only a few buses. It could be because the contract is demanding this, but it could also be on a voluntary basis because they want to start with some buses to learn. But the problem has been in many cases is that they have no vision of what will be in the depot on a longer term. Yeah, and in fact they have learned a couple of things. They have learned how to drive electric bus. They have learned how to regenerate electricity, also charging buses, but without knowing what will be needed in terms of battery capacity and charging power when you have a larger bus fleet. So in some countries, sorry.
1 second. Can you please put the presentation in full screen mode and jump to slide number 7?
I have it in full screen mode here. Right?
Yes, we see it. Yeah, this happens sometimes in Teams. Yes.
Okay.
We see just the first slide. Can you stop sharing and sharing again? This happens often in Teams. I had it as well.
Okay, oh, just a moment. I will try to get out. Yeah. So,
That's weird. It's not showing.
now I have a full screen again.
Yeah. No, it's not showing for us. Okay. I can do the following. I can share my screen and you let me know if it's displaying correctly and I click for you.
Okay, okay, very well.
Yeah, let's do that. I don't know what is this strange bug from Teams, but it's definitely something I have also experienced in the past.
Okay, okay.
Should be now able to see my screen also in full screen mode.
Yeah, and I don't see it in a full screen mode. There's no problem for me, of course, but
Weird. Do participants can see the full screen mode?
Yes.
Yeah.
okay. Then I can work this way. I don't see the full screen, but it's no problem for me.
Okay.
So can you click on it, Ida? Yeah, so we had this one. The comment is that I have to give is the following. In some countries with a new contract, a large fleet of electric buses were requested. And the plan for the introduction of more e-buses during the contract period is demanded at the same time. This means that the study how to manage the total fleet was done from the beginning. In other countries or regions, electric buses have to be introduced when replacing diesel buses because of age restrictions. So step by step, you implement electric buses. In these cases, it happens that buses are bought only concerning the operation the buses have to fulfill, and that they are replacing those diesel buses. And the charging infrastructure is also restricted to what is needed to do this. As a consequence, it could happen that the first number of buses doesn't fit in the larger fleet, and this can also be the case with the already installed charging infrastructure. So developing a charging infrastructure within a bus depot will be done according to the local operational circumstances. This means that copy-paste the solution towards another bus depot is not always possible. Yeah. Within this presentation, I'm trying to give you some guidelines and points of attention when developing a bus, an electric bus operation. So Ida, yes, please. Can I have the next slide? Yes. So yeah, this is a drawing showing an overview of all the steps that you have to go through when developing a zero emission bus system. Depending on the circumstances, the impact of several of these steps may be different. Yeah. As an example, the timetable. We see in some countries that electric buses must be used to replace diesel buses on lines that were not designed for them. So you have to be able to put those buses on those lines, and it gives you another challenge, of course. Next, please. There we have an overview of the stakeholders. The subjects we will discuss is about the grid, the energy grid, is about bus specifications, is about planning, and not only planning the buses on the routes, but also planning the charging. And then we have the charging infrastructure itself. So you need to have internal people involved, like planners and engineers, technical staff, dispatchers in some ways, but you also need to talk with external people like the network operator, the energy provider, bus manufacturers, and so on. And you need software support. Yeah, so we will discuss this during the presentation. Like I said, many issues need to be addressed. External consultants have to be called in, but in addition, of course, if you lack the competence in-house, maybe you need also consultants for what is mentioned here in the list as the internal people to be involved. Next one, please. So the planning, what do you need to investigate before planning electric buses in operation? What do you need as an amount of energy to be taken from the grid? As if you would go for a total conversion to electric buses from the start, yeah? And what should be the capacity of the batteries of the buses that you will use? It is recommended to build in as much as flexibility within your fleet. This means that all buses within the same contract should have a similar range of operation, so that you're able to switch buses. Sometimes buses can be used over several contracts, built-in flexibility over these contracts. Yeah. What charging technology will you use? Charging at the depot with cable and plug, or in combination with opportunity charging on public domain. This means if you consider public domain, then you need to have agreements with the cities, with the villages, where you need to install charging equipment. Yeah. What is the maximum charging capacity we will need during the day? So you can calculate what you need in total, but you don't need all that energy at the same time. So what is then the peak that you will have? And this is depending on the kilometer load of the fleet and the expected energy consumption. So how will we plan bus services taking into account the range of the buses? So you need a planning tool that takes into account that range of the electric buses. Otherwise, it will be difficult. Yeah. Next one, please. What needs to be investigated? Again, how do we compose a charging plan? You don't only have to plan the vehicles on the routes, but you need to plan the charging. Yeah. Can I replace, next one, can I replace a diesel bus with an electric bus one by one? It could be that you will need more buses, as the combination of bus services could be different compared to diesel buses. And it could also be that you need to replace a bus during operation because the range of the bus is not high enough to do the route completely. Yes, please. How can you save on costs while charging? Reducing the peak consumption of electricity. So don't charge too many buses at the same time. Charging when electricity is cheaper. So develop a charging strategy with shifting charging towards periods where it is cheaper, but with limiting the peak consumption. A remark is that in several countries are trying to decongest the grid by introducing a capacity tariff. So charging too many buses in a period where electricity is normally cheaper could still lead to a higher cost. So you have to be taking care of this. Next one, please. So have a vision on how big the fleet of e-buses would be in the future. Develop the charging infrastructure step by step, but with a view of what it should look like when all buses are electric. Knowing how the charging infrastructure should be composed when the entire fleet is electric, and split the composition of that infrastructure into phases in relation to the step-by-step introduction of e-buses, and build the infrastructure in this way. Besides the expected fleet size, what is the size of the battery pack needed to cope with the bus services? A homogeneous pack size is recommended for the entire fleet of buses on the same services. Next, please. What do we need to take from the grid? Do we need 1 megavolt amp connection or 2 megavolt? Depending on what we need at each moment of the day. This depends on the size of the peak load you will have. With a smart charging program, you can reduce the peak load as much as possible. This will lead to a lower electricity bill, and you can save on some of your charging infrastructure. I'm thinking about the size of the transformers. This will exceed the grid connection a diesel or a CNG bus depot has today. This means that it is obvious that the diesel depot you don't have the capacity to charge a fleet of electric buses. So a more important grid connection will have to be installed. It is recommended to provide a connection that will enable us to supply sufficient energy when the e-bus fleet is complete. Yeah, so from the start, in fact. Is your energy supplier able to deliver this energy demand? That's a big question. Knowing what you will need in the future, can he do that? A medium voltage connection, a 400-volt connection, is sufficient to be able to charge 2 or 3 buses each day. But for a larger fleet, a high voltage connection will be necessary. And depending on what is available in your region, this is usually between 10,000 and 20,000 volt connections. Yeah. Now, is this available at your site? Even if it is available, can they supply the demand on longer term? If not, it would mean that not all the e-buses can be charged at the site. Do you have an additional location where you can charge? Can you combine in-depot charging with charging on public domain? This would mean that in your depot you would need a smaller demand from the grid. Should you consider moving the depot to another site? And this is really to avoid the cost of installing the charging infrastructure and having to transfer everything to another location on a later date. Yeah, consider the energy supplier able to deliver enough when you have a complete fleet of electric buses. So how do we proceed? We must distinguish two things. There is the physical connection to the network. We say the copper in the ground. And there is the delivery of the electricity over the network. Mostly those are two different companies, at least in Europe. Order a new connection to the grid with cables to supply the maximum demand over time. Then make a contract with your supplier limited to the size of the energy you will need at the start, and have the contract changed anytime you add electric buses to your demand is rising. So if you have to change the connection every time you have more buses, then they open the public domain to connect the wire. It will be much more expensive. Next one, please. How to build your charging infrastructure? Well, the first thing you will have a connection to a high power electricity network. The first thing is an electric cabinet where a power transformer will be installed. Now, we were saying that you need the cable for the maximum energy transfer that you will need in the future, but you don't have to install a power transformer that is able to deliver this when the fleet is complete, especially not when it takes years to come to that situation. Now, a transformer that can handle the need in the first years should be installed. Yeah, but this cabinet will function in the future as the main cabinet. Later, when more energy is needed, one or more satellite cabinets should be installed, connected to the high voltage grid over the main cabinet. Now, a remark I have to give to you, normally the size of a cabinet depends on the size of the transformer. But here you have to take in account that you need also to have high voltage connections to the satellite cabinets in the future. And therefore space must be foreseen to accommodate the departure modules that you will have to install later. Otherwise, you have to change your cabinet again. And this is not an easy thing to do. Okay, next one, please. Then we have the battery chargers itself. The energy that needs to be charged at each bus depot depends on the consumption in kilowatt hour per kilometer of the buses, and of course the length of each service in kilometers. The charging power necessary to charge these buses is depending on the time available to charge these buses and the energy needed to charge at night and in between the shifts over the day. So some examples. If I need to charge 120 kilowatts between shifts and I have 2.5 hours time to do that, I can do that easily with a 60 kilowatt charger. If I only have 1.5 hours to do this, then I need a 120 kilowatt charger. And in a half an hour, then I have to go to a 300 kilowatt charger. So the advice is don't use a large capacity, charging capacity if there is enough time to charge with a lower capacity. It's even better for the lifetime of your batteries. Next one, please. Which type of charging should we use? Cable and plug charging is possible till 150 kilowatt charging power. Now, today there are possibilities to charge higher power with cable and plug, but it concerns mostly cables that are cooled. Yeah. So below 150 kilowatts charging, you don't need cooled cables. It's an easier thing. For higher charging power should be done with a pantograph. And you have two types of pantograph. You have the pantograph on the bus that goes up, and you have the pantograph on a totem or on the roof that goes down. Yeah. But there are other things to consider too. This is the preconditioning of the batteries and the buses. And this is also part of the charging plant. We have to take this in account. It is needed when charging has finished sometime before starting the service. Because we want to shift a little bit the charging to avoid to have too high peaks of charging demand, of energy demand. It can be that a bus has been charged and it takes another hour or 2 hours before the bus goes in operation. So what is it? Is in fact the preconditioning phase that we will include then is heating up the batteries to operating temperature. It's saving the battery life, and it's avoid also that you use already energy stored in the batteries to heat up the batteries. Yeah. So loss of range at that time. So maintaining the temperature of the bus interior in winter, you can use that preconditioning phase to heat up the bus. And some brands are also assuring the pressure and the air circuit in this phase. Yeah, with diesel buses, it was simple. If you start the bus and the bus has not enough pressure, then you can let the engine run for a couple of minutes, but this is not the case here. So in that preconditioning phase, some brands already foresee that at the same time, the compressor will run and the pressure is on the correct level. Okay. Another thing to keep in mind is the balancing of the battery cells. When do we have to do that? It's charging with high charging power. This is mostly when you charge with a C factor, which is more than 1. And buses with large battery capacities and or limited time to charge. Yeah. This is leading to voltage differences between the battery cells. I must say it depends on the battery technology. There are technologies where you don't have to do balancing. But if you have this, then you need to plan this also in your charging plan. Why balancing, Ida? It's assuring the lifetime of the batteries, of course. And how doing this is foresee a charging session with low charging power once a day or once a week, and this is depending on the constructor's instructions. Yeah, and this is also part of the charging plan. Okay. Now, how to plan the preparation is, in fact, how to build your charging infrastructure. Charging and pantograph charging is sometimes used in depots, even with lower charging capacity or charging powers to save space. So the picture on the left shows pantograph charging in the public domain, with a charging point placed on a totem. But such charging points can also be suspended from the ceiling in a depot without a totem. This saves space and can also be part of a procedure in which the driver secures the connection from the bus to the charger. When loading with cable and plug, drivers may not make the connection. It depends a bit from operation to operation, country to country, what the rules are. But in this case, it can be that they are not refueling the diesel buses. It can be that they are also not connecting the vehicle. So with the Panto, it could be a solution to avoid this. When charging with cable and plug, we must ensure that the cables are not driven over. Applications where the cables are suspended will avoid this. And this is the picture on the right, or the drawing on the right, I should say, where the cable is not lying on the floor so that the buses cannot run over it. Okay. Yes, Ida? So managing operations. The first thing you need is a planning tool. Software is recommended that takes this in account. What is taken in is the available battery capacity of the vehicles you have in the operation. The capacity lies mostly between 64 and 72% of the new capacity. And this is depending on the technology and the manufacturer's warranty conditions. So as an example, if I have a battery capacity new of 480 kilowatt hours, then the available battery capacity of 64% is 308 kilowatt hours. The manufacturers also call this end-of-life capacity. This is because, of course, you need to respect a certain depth of discharge, and otherwise you can lose battery capacity during the years. So if you work with this, you can do that year after year till the batteries have to be replaced. Yeah. Okay. Then you have an e-bus management tool. And in that e-bus management tool, you need to have an electric bus database. Yeah. What should be in? This is the bus brand and type with battery specifications, with energy consumptions, according to the experience you have on the different lines. And yeah, perhaps there is already a bus database available in your organization. Then it should be completed with this data, electric bus data, and linked to the e-bus management tool. Managing the fleet of chargers. This is the charger database you need in that system. And a charger brand and type with number of charging points, because some chargers can have 2 connections or 3 connections. The charging capacity maximum and per charging point, if partly or all connected together. And of course, where is the charger located? Okay. Composing the charging plan and activating the charging is also done with this tool, taking in account the periods available for charging, adjusted in real time, yeah. Applying smart charging, spreading the charging sessions and monitoring the peak charge, shifting charging to periods of the day when electricity is cheaper. So this should all be done in the tool, together with what's mentioned on the next slide. And yes, so we have done the calculations about everything about the charging, but then we need to monitor what's happening during the operation. So the state of charge has to be monitored and the energy consumption. Charging sessions planned according to the periods available for charging. Yeah, it's nice to have a tool that has put together a charging plan in function of these services, but what if circumstances prevent this plan from being kept? You can have incidents during operation, which means that a bus has to be replaced during operation, and that bus was then planned for another operation, also with its charging plan. So you need to have a system that can adapt to this. And then, of course, at the end, we need a reporting system on fleet level, on charging level, on operation level, and energy consumption level. And the aim is measuring is knowing. From this information, we can introduce improvements with the aim of reducing the cost of the operation. Okay. And then I can show you a case study. And it is a case study where a diesel service has to be transferred or converted to an electric bus service. The operational data of the part I will show you is that there are 27 services to be run. Those services have a length of 62 to 244 kilometers, and they are operated with 12-meter electric buses. Well, they were operated, of course, with diesel buses, now with electric buses, and these services with diesel buses were only 22 units because some services were combined. The battery capacity of the buses that were selected is 490 kilowatt hours, and the available battery capacity, which is those 64%, of the new capacity is in this case 313 kilowatt hour. So we charge batteries here always not to 490, but to 313 kilowatt hours. We expect for those operations an energy consumption that will vary between 1.1 and 1.3 kilowatt hours per kilometer. So we first check how much energy we consume while driving these services and how much residual energy is left in the batteries after the first service and how much energy must be charged between two services to be able to do the second shift. Okay, so then we check those services as we are running them with electric buses, with the diesel buses. And we want to have, can you click, Ida? Yes, can you?
Yes, I'm clicking and it does.
It doesn't. Okay.
But sometimes takes some seconds. Sorry for
okay. So we want to keep an energy reserve of 40 kilowatts at each time. Huh? So if we look what we have been running with diesels, we notice that there is a problem to finish 5 services or to guarantee the reserve when the consumption rises to a higher level. Huh? Yes. It's a bit retarded, I see. Yeah. There we have an overview. We have 5 services with the service number, with the starting time and the end time and the duration of the service and the distances. So the distances here are going from 227 to 244 kilometers. And if I look, so then we have the energy consumed. And then on the right, you have the residual energy of the batteries. Starting with 313 kilowatts. And red is a service that you cannot finish. So we see service 134, the first bus, with a consumption of 1.3 kilowatt hours per kilometer. You will not even be able to finish the service. And all those in orange are services where we have a less energy reserve of 40 kilowatts. So can you click again? We will have to split up services and thus be able to reduce the kilometer load. So as a consequence, the screen is disturbed, Ida. Okay.
Are you seeing now the right image, the right slide? I am in. I see the point energy consumption residual energy. Is correct for you?
Yeah, just a moment. Yeah, that's a good one. Yeah. Okay. So we want to keep that energy of 40 kilowatts at the end of each line at a minimum. Can you click again, please? As a result, we need 23 buses. So this is 1 bus more than we had with diesel buses. So this is something very important, especially if you calculate for a tender. Yeah. Now, a charging strategy is chosen for this case. So during the day, we only charge the energy needed to complete the second shift with the residual energy of 40 kilowatts. And those services, can you click again? Those services where we expect to have 40 kilowatt over after a second shift without charging in between 2 shifts, we will keep it that way. We will not charge. So the idea here was to charge as much as possible during the night and this way have cheaper electricity. Okay. Can you click, Ida? Yeah, it's coming. So here we have the first 10 buses of that overview of 23 buses. If you look to bus 1, he's starting with line 101. Start at 5:01 in the morning till 8:25 in the evening. And in fact, we are not completing because that service 101 in totally, which we saw on the screen before, is 227 kilometers. Yeah, so we only do 114 of those kilometers because the bus is arriving at 8:25 at the railway station, and the railway station is only, in this case, at 3 kilometers away from the depot. So what we will do there, we will have bus 3 awaiting at the railway station. And that bus 3, if you go to the line with bus 3, you see that 101 is there mentioned too. And this one is starting at 9:05. So we even have, what is it, 30 minutes waiting, or 40 minutes waiting time at the railway station. So it's easy to change a bus over there. So then he is running the rest of the 143 kilometers for that service. Yeah. Now, if we go back to bus number 1, you see that he will start another service in the afternoon at 13:28. That's service 103. And this is a service of 120 kilometers. So that bus will run in total that day 234 kilometers. So in the columns H and I, you will see the times that we have available for charging. The first column, the H column, is in fact 5 hours and 13 minutes is a time that we have to charge in between the two daily services, and 10 hours and 30 minutes is at night. Yeah? Okay, then we go to the next columns, G, K, and L. That's the energy consumption that we have done during the ride, in between from 1.1 to 1.3 kilowatt hours per kilometer. You see that energy consumption is about 125 to 148 kilowatts. Now I'm interested to see what is left in my battery. So you know that we started with 313 kilowatts. We consumed at the lowest consumption 125, so we still have 188 kilowatts in the batteries. Now, what do we need for the second shift? We need for the second shift, and then you have to go below. You see that the bus will consume still at 1.1 kilowatt hour per kilometer, will need 132 kilowatts. And that 132 is, then we have 56 kilowatt left. That's in column P. Yeah, I put it in green because what does it mean? This means that if we don't charge the bus over day, we still will have 56 kilowatt hours of energy left in the batteries. Yeah. So if you then go to column S, it's mentioned 0. This is the charging power that we select. We will not charge that bus. Don't forget, we have to put it on the charger anyway for the preconditioning phase. Yeah. So if you go to column V, this is the energy in the battery which we start that second phase, that second shift, sorry. And this is of course the same as the residual value we had after the first shift because we are not charging. Yeah. If the consumption for that bus would be a bit higher, let's have a look at 1.2 kilowatt hours per kilometer. There is mentioned that the residual value, if we don't charge in between shift 1 and 2, would only be 32 kilowatt. Yeah, so that's 8 kilowatt less than the 40 kilowatt we have in mind. Yeah, so we have to charge with 8 kilowatt. 8 kilowatt, that's a small amount of charging. We can easily do that during the preconditioning phase. Yeah, so that bus doesn't need another treatment when it has 1.1 or 1.2 kilowatt of consumption per kilometer. But this means if we then look to the last part of the table, Y, Z, and AA, you see that the residual value after the second service for the lowest consumption is 56. That's what we already calculated. And for the others, it will be 40 or a bit more, yeah, a little bit more. So if you go below to bus number 10, there you have another situation where you have to change buses 2 times. Yeah, you start with service 114, 2 in the morning till 13:05 in the afternoon for 140 kilometers. That bus has to be replaced at the depot because that bus is coming in, and you shift then the service to bus number 9. So you will find service 114 back with bus number 9. And then in the afternoon, bus number 10 will start with the service 137 at 1550 till 1957 for another 128 kilometers. But this is also not a complete shift, because at 2005, at the railway station, the shift is taken over by bus number 14. So you see that it's a bit more complex because of the limitations to the range, and the battery pack that has been chosen to do those services is in fact the biggest one you can have in that vehicle. Yeah. So that part that I'm explaining should be done by your planning tool that takes in account the capacity of the batteries, the range they can do, and that's splitting all those services in a way that you can handle this. On the other hand, the right part of the table is in fact what your e-bus management system should do, is selecting which charging power that you need. Yeah. Can you go to the second page, Ida? The following page. Yeah, that's the other buses, 11 to 23. I will not go in detail because it's the same principle. Here we have a couple of vehicles which are doing only one shift. For example, bus number 15, service 119, 203 kilometers. So he can handle this. Another one is bus 18 with 210. So those lines are not too long for that bus. Okay, and you see then that the residual value, because we have no way to charge, or it is at night. It's for bus 15 in with the biggest consumption, it's still 49. For bus 18, it's still 40, the minimum we wanted. And for buses 21, 22, it's 17 and 69. So it can be done. We need that battery capacity to do this. Okay, go to the next one. So we just calculated what we need, but when do you do it? So if you look to this graph, you have two vertical lines. In between those vertical lines, you have a complete day, 24 hours. So in green, you have the services, the length of the services. Shift 1 and shift 2 on some buses, only one shift on others. You have the blue fields, which is the charging power that you need. In this case, it's always 60 kilowatt. And in the transparent blocks, you have the preconditioning. Now, I draw your attention to the fact that a lot of buses are starting. It's a bit small, but you can see it's around 5 o'clock in the morning, between 5 and 6, 6:30. There's a lot of buses starting. So all that preconditioning has to be done just before, meaning that you need a lot of connections. Okay. Next one. So number of charges, what will you need as charges? And this is depending on the procedure. So the first thing is that we place the driver. The driver places the bus in front of any charger and connects the cable. That's the most simple way of working. Yeah. If exceptionally a higher capacity load, so I was saying to you that we work with 60 kilowatt all the time, but the charger can deliver 120, but then only one bus can be charged at the same time. Why would we need 120 kilowatts? Because we said that e-bus managing system is monitoring what's happening during the day. It can be that with delay of buses, with buses that you have to change to shift or to swap with another bus, that at a certain moment your time to charge becomes too small and you need a higher capacity. Yeah. So in this case, it has to be indicated which connection should be used. Currently, it's only one bus can be connected to the second connection point that is not to be charged directly. Yeah? So this is because the second connection to this charger is not active as long as a 120 kilowatt charging capacity is drawn from the first point. If such situations regularly occur in an operation, because here it is only marginal, it is advisable to install a portal with the bus number and indication of the charger where they should place the bus and which can be seen by the driver when entering the station or the depot. Yeah. The consequences of this way of working and also of the planning I showed you before is that we need a connection point for every bus. Yeah. It is possible to save on charges, but then one has to disconnect buses and connect other buses on a regular basis to the chargers. This means moving buses during the day and the night. The extra cost of chargers will compensate for the extra cost of staff to carry out these operations within a few years. Now, you have a fleet of battery chargers, and the option that we have here for this operation is to have charger with a capacity of a maximum of 120 kilowatts and 2 connections. So you can charge 2 buses at the same time with both 60 kilowatts, or you charge one on 1 connection with 120 kilowatts. And we will need 12 chargers to do that. Another option is to have a charger with 3 connections, 3 times 60, with the possibility to charge at a maximum 180 kilowatts. There you need 8 chargers instead of 12. Is this a saving? Not really, because if you have a charger with 2 connections, you can easily with a cable connect 2 buses with cable lengths which are having the same length. If you have to charge 3 buses, then you need a system with dispensers, where the dispenser is hanging then in front of the bus to be charged, and of all of the 3 buses, of course. Yeah? So this is then an extra cost to place those dispensers. Okay. And yeah, this is a picture with those possibilities. Above you see the 120 charger or 2 times 60, and below you see 180 with 3 times 60. But you can also have 120 on one, 60 on the second one, and nothing on the third one. So there are possibilities there. Okay. So thank you very much, and I'm looking forward to questions.
Thanks a lot, Marc. We have had some initial reactions also in the chat, but I think I would invite everyone just to raise his hand and make the question themselves. For instance, we had Philip. Hi, Philip. You were asking, what about charging at the depot with automatic charging? I think we have covered that along the presentation, but
Yes. In fact, sorry, Philip speaking. Thank you, Marc, for this very synthetic and clear presentation. It was just in one of his slides, he was mentioning depot charging with cable plug, but afterwards in his presentation, he has mentioned that, of course, automatic charging in depot was possible. It was just, my reaction was at this very first slide was you were mentioning cable plug in depot, but afterwards, yes, clarify the point.
No problem, Philip. Nice to hear you again. Yeah.
And I had another question, which was battery balancing. You mentioned that we need battery balancing, but I was just asking the question that's or trying to clarify the point that perhaps this point is also according to the battery technology which should be used, because there are there are clearly some battery techno which ask for battery balancing and it's mandatory, and some others, as you mentioned, it was mainly to improve the lifetime, if I've understood.
There's technologies where you don't have to do balancing. Okay.
Perfect. Thanks a lot, Philip and Marc. I also saw an interesting question from Rutger.
Yes, hello, Rutger Hörndahl from Scania. Thank you, Marc, for a very good and interesting presentation and cover this topic in a very pedagogic way. Just one comment here. What we're seeing, and we are also participating in interesting projects here in Sweden, is that besides the energy price and availability market, as you describe in a good way, it is also a market that are going to be start up when they come to the frequency balancing market. That also can be added on top of this. And that is also connected to local energy storage, where preferably used bus batteries can be used in the future. So that gives even more possibilities in the future to consider. That was just my comment. So this is an interesting possibilities for the future that I
I
wanted to mention.
Fully agree with you, Rutger. I didn't want to put that in the presentation because we're talking about starting up. So most of the depots I saw, they don't have yet that possibility. But don't forget that when the first batteries will be replaced after half of lifetime of a bus, I expect, then there's also possibility to store energy in those batteries and to use it in the buses afterwards. Yeah. Okay.
Thanks a lot, Rutger, for that. Andrea, would you like to address the question yourself?
Two questions in particular, two questions. The objective to have a homogeneous pack battery for the fleet is possible in the fast changing market of the battery is realistic, because we have a change in the battery capacity and type every 6 months. It's possible that the operator try to have homogeneity, or is in fact in reality not possible? And the other question is, have you information about second life battery? Because everybody talk about that, but in reality, if you buy a buses in this moment, the maximum that you can have is that the constructor take back the battery as a waste.
Yeah. Okay. Coming to your first question, of course, it's not always possible, but to have a homogeneous size of battery capacity. But the meaning of that line was to say, if you start buying buses, don't just look to the lines those buses have to work on. If you have then other lines coming up later where you put electric buses on, and there you need a higher capacity, why not having also those first buses with that capacity? So then you have more flexibility to swap buses if necessary, and to put buses on longer lines to let's say balance a bit the kilometer load on the vehicles. So, but I understand what you're saying. It's not always possible to do that. Now, another question with batteries as a waste, I don't think so. We will see. If you start now with batteries, you can expect that in 7-8 years you have to replace them, and there will be a market for this. The thing is, if you change batteries after 8 years, it will be another technology. You will have less batteries for the same capacity, or you will have more capacity out of the batteries for the weight of the batteries that you will install. But you will also have to work with the bus manufacturer, because there is still the battery management system that is making the communication between batteries and between the charger. And maybe there it needs some new software, and this can only be done by the bus manufacturer. So you're a bit linked to the bus manufacturer for doing this. But there are already companies who are proposing to you that they are buying the batteries for you. So you buy a bus without batteries, or they even buy the bus for you. And because they are interested to recuperate the batteries after the first life, because there will be a huge business case in using those batteries. Batteries are not wrong. The only thing is they have lost capacity, and they are not fitted anymore to run the services as you were planning. And we expect that there will be a big business case on this. So yeah, there will not be a waste. No, I don't think so.
No, Rutger, I can just add, I fully agree with you, Mark. I think that is also what we see from the manufacturer side, this development, and from Scania side, we develop this part also very heavily together with our battery suppliers. What we also see, I mean, then we're coming also to LCA and the sourcing of material and the social aspects in the supply chain of materials for battery electric buses. So of course, also the material in the battery as such has a value connecting to taking material from the ground again. So thinking from the circular economy perspective in this is very crucial for the sustainability of the e-bus systems.
Exactly. But this could be done after the second life.
Yes, exactly.
Okay.
Thank you very much. We have 1 minute left. I would encourage participants to make perhaps the last question. Of course, slides will be shared and uploaded on the Clean Bus Europe platform website as usual, also with a recording of the session. So you will be able to go through the session again and catch up there if any aspect was needed. And if there is no more questions, I would then just like Marc to thank Marc again for a fantastic, complete, very much in detail presentation. It's always a pleasure to have you as a speaker, sharing with you so much expertise gathered in your career, and we are very happy that we can still cooperate together in this. Thank you also to everyone for joining today. I think it has been a very nice round. We have also not members of the Clean Bus Europe platform. We have also members of the UITP bus committee and also some industry partners as well. So that was a very interesting, nice, diverse group today. And also thank you for indeed the very interesting discussion at the question round. I would like to share with you just one last thing. We are organizing in the frame of the Clean Bus Europe platform, as you know, the first study tour. This time we're going to the Netherlands, so very much related to the presentations, also and the insights that Marc has shared with you. You can have more information by contacting me. Please, this is more targeting the members of the Clean Bus Europe platform, the cities and the operators. But if you are especially interested in this study tour, please just contact me and we will discuss about that. So yeah, that's it from our side. Thank you everyone, and we hope to see you and meet you soon. Have a good end of the day. Thanks again, Marc, and yeah.
My pleasure. Thank you. Bye-bye.
Bye-bye. Thank you.
Bye-bye.
Bye-bye, everyone.